Welcome to G Fun Facts Online, the show that dives deep into the science behind the world around us. Today, we're talking about an invisible threat, a danger that lurks in factories and workshops all over the world, born from a substance so common we barely notice it: dust. We're not talking about the dust bunnies under your bed. We're talking about fine, airborne particles that, under the right conditions, can unleash a catastrophic force. This is the world of combustible dust, and the explosions it can fuel are some of the most devastating industrial accidents imaginable. So how can something as simple as dust become so deadly, and what can we do to stop it? Let's find out. To understand a dust explosion, we need to understand what scientists call the Dust Explosion Pentagon. Think of it as a recipe for disaster. You need 5 specific ingredients, and if you take away just one, the explosion can't happen. The first ingredient is the fuel, combustible dust itself. Now, not all dust is explosive, but a shocking number of materials become combustible when they're ground into a fine powder. We're talking about things like flour, sugar, starch, powdered milk, spices, sawdust, plastic particles, and even certain metals like aluminum and magnesium. The smaller the particle, the more surface area it has, and the more violently it can burn. The second ingredient is the oxidant, which is almost always the oxygen in the air around us. Nothing special needed here. The air we breathe is usually more than enough to fuel the fire. Third, we need dispersion. The dust can't just be sitting in a pile. It needs to be suspended in the air, forming a cloud. There's a sweet spot for the concentration of this cloud. If it's too thin, there isn't enough fuel. If it's too thick, there isn't enough oxygen to mix with it. But when the concentration is just right, you have an explosive atmosphere. The fourth ingredient is an ignition source. This is the spark that lights the fuse. And it's a huge misconception that you need a big, open flame. In fact, more than half of dust explosions are triggered by things other than flames. It could be a spark from faulty electrical equipment, a bit of static electricity, friction from a moving machine part, or even just a very hot surface like an overheated motor. The fifth and final ingredient is confinement. This is what turns a rapid fire into a devastating explosion. When that dust cloud ignites inside an enclosed space, like a room, a silo, or a piece of machinery, it acts like a pressure cooker. The rapidly expanding gases have nowhere to go, and the pressure builds and builds until it blasts the structure apart. When all 5 of these elements come together, you get what's called a primary dust explosion. This initial blast can be destructive on its own, but the real catastrophe is often what comes next: the secondary explosion. The shockwave from the first blast can shake an entire facility, knocking loose all the dust that is accumulated on rafters, equipment, and ledges. This creates a new, much larger, and more widespread dust cloud. When this massive cloud ignites, the secondary explosion is often far more powerful than the first, capable of leveling entire buildings. This isn't a theoretical problem. The list of industries at high risk is long and diverse. The agriculture and food processing industries are constantly dealing with dust from grain, flour, and sugar. Woodworking facilities are filled with fine sawdust. Metalworking shops can create highly explosive dust from aluminum or titanium. Even modern industries like pharmaceuticals, plastics manufacturing, and 3D printing with powdered materials face this hidden danger. The tragic history of these events serves as a stark reminder of the stakes. Take the Imperial Sugar Refinery explosion in Port Wentworth, Georgia, back in 2008. On February 7th, a massive explosion ripped through the facility, ultimately killing 14 people and injuring 38 more. Investigators from the U.S. Chemical Safety Board found that the explosion was fueled by colossal amounts of sugar dust that had built up all over the packaging building. A conveyor belt used to transport sugar was enclosed in a tunnel, which allowed an explosive concentration of dust to form. The likely ignition source? A single overheated bearing in that conveyor system. That was the primary explosion. The shockwave then triggered a series of horrific secondary explosions that propagated throughout the refinery, fueled by years of accumulated sugar dust on every available surface, a direct result of poor housekeeping. Another case occurred in 2003 at the West Pharmaceutical Services plant in North Carolina. An explosion fueled by fine plastic powder destroyed the facility, killing 6 workers. The investigation found that the plastic dust had collected in a hidden space above a suspended ceiling. No one saw it, but the danger was there, waiting for an ignition source. These tragedies, and so many others, share common themes: a failure to see and assess the risk, inadequate cleaning, and poorly maintained equipment. They prove that dust explosions are preventable. So how do we do it? How do we disarm this invisible threat? The strategy is a multi-layered approach that aims to break the dust explosion pentagon. The first and most fundamental line of defense is simply good housekeeping. It's a simple principle: if the dust isn't there, it can't explode. This means a rigorous, regular cleaning schedule for the entire facility. Floors, walls, and especially overhead areas like light fixtures and the tops of machines where dust loves to settle. And the cleaning method matters. Using compressed air or sweeping with a broom is one of the worst things you can do, as it just throws the dust up into the air, creating the very cloud you're trying to prevent. The best method is to use industrial vacuum cleaners that are specifically designed for collecting combustible dust, built to prevent any static electricity buildup. The National Fire Protection Association, or NFPA, has a guideline that is shockingly specific. Cleaning should be done when dust accumulation reaches just 1/32 of an inch, about the thickness of a paperclip, over just 5% of a room's surface area. Beyond cleaning, we have engineering controls, which are ways of designing safety directly into the facility. Dust collection systems are essential. These are basically powerful, localized vacuum systems that capture dust right where it's made, before it has a chance to escape into the work environment. Another critical control is managing ignition sources. This means using explosion-proof electrical equipment, grounding machinery to prevent static buildup, banning smoking and open flames, and having strict procedures for any hot work like welding. Then there are the systems that kick in if an explosion does start. Explosion venting provides a planned escape route. It involves placing panels or vents on equipment that are designed to burst at a set pressure, safely directing the force of the explosion outdoors before it can destroy the container. If venting isn't possible, you can use an explosion suppression system. These are active systems with sensors that can detect the very beginning of an explosion. In a fraction of a second, they discharge a chemical agent that extinguishes the flame before it can grow. Finally, there are isolation systems. These are crucial for preventing a primary explosion from causing a secondary one. They use things like high-speed gate valves or chemical barriers to instantly block the ducts and pipes connecting different pieces of equipment, stopping the explosion from spreading through the facility. Tying all of this together is a process called a dust hazard analysis, or DHA. Mandated by safety standards like NFPA 652, a DHA is a systematic review of a facility to identify every potential dust hazard and every possible ignition source. It's the blueprint for safety, creating a prioritized action plan to fix problems before they can cause a disaster. In the US, both OSHA and the NFPA provide extensive standards and guidelines to help industries manage these risks. Compliance isn't just about following rules, it's about saving lives. And the field continues to evolve. Researchers are developing advanced sensors for real-time dust monitoring, using the Internet of Things for predictive maintenance to catch things like overheating parts, and even applying AI to conduct more accurate risk assessments. The threat of industrial dust explosions is very real, and the consequences are devastating. But these events are not inevitable accidents. They are preventable failures. Through a solid understanding of the science, a commitment to rigorous housekeeping and engineering controls, and a culture where safety is everyone's top priority, this invisible threat can be managed. The lessons from past tragedies have given us a clear roadmap: The responsibility falls on everyone in these industries to remain vigilant and to never, ever underestimate the power of dust. Thanks for listening to G Fun Facts Online.